Hello guys, welcome to a new video of, well, of nothing really, but there is something in this video still, so don't click off yet, because this video is the first episode of Boolean Algebera. If you already know what it is and you want to skip the tutorial, you can go to video 2. It's probably in the description, except if you're watching this and the video is uploaded 2 seconds ago. But this video is the tutorial and guide for a beginner Boolean algebra. And in this video, I recommend you use Minecraft. If you don't have Minecraft, that's okay. You can just follow everything we do using this link. The link is also in the description. But let's get into it. The reason we are later going to use Minecraft is that Minecraft also has a bit of building. You actually need to build what you have for the logic. Here, for example, this, by the way, in the future you're definitely going to understand. An XOR gate is just simply one block. But in Minecraft, you need to actually have some fun. So I recommend you use Minecraft, but if you can't, just use this link like I said before. Anyway, here's the tutorial. What is Boolean algebra? Well, Boolean algebra is a programming type where you use booleans and algebras to make a type of game or something, just anything, software or, well, something. For example, if you want a game where you input 1 or 0 and you get a output of that exact same thing. And here we can simply wire it. Let's do that. Ta-da! So here we have 1 and here is also a 1. We turn it into 0, it also becomes 0. Well, now, what if we want the output to be opposite? Well, the only way to do that is to use our gate. Ta-da! Let's speak about all of this. First, the OR gate. Let's say that we have an input and another input. Like that. The OR gate checks if one of them or both is on and then sends the output yes or no. And it sends it into the item. By the way, this is a bit. It doesn't matter right now, but it does in the next episode. 1 is basically yes and 0 is no. Since you can see that one of them, at least one of them is on, it is sending the output correct. None of them are on, but if we turn this one on, it's still sending the output correct. Now let's put both of them on, still sending the output correct. But now what if we want the output only if both of them are on? Here we need the AND gate. The AND gate checks if both of them is on and sends the output. Let's quickly make a circuit like this and let's test it. Right now nothing is on, but if we put both of them on, it turns on. Well, what if we just want one input and one output? But I don't want it to be the exact same, because I want it to be opposite. Well, we can't do that here, right? Because, like, what can you do? But there is a way. There is a way. There is a way. Let's take the NOT gate. Sends the opposite of what's the input. If we put it like this, and then send it like this. If we put on 0, it outputs 1. If we put in 1, it outputs 0. And also you can change the NOT gate into AND gates and OR gates, by the way. Don't forget the OR gates. Let's quickly test it. Let's quickly remove everything here. Boom the clut. That's weird. Why did I say that? So, you can either use the built-in AND or NAND gate. It kind of speaks for itself. Or you can use real wiring and use the AND and the NOT gate right behind each other. Like this. We have a input and we have an output. For example, let's input that and input that. It's one except if both are on. Crazy, right? Well, there's still one more thing I want to show you. The XOR gate. And also there's an XNOR gate. And not an XOR gate. The XOR gate. It's basically, it stands for the exclusive OR gate. The meaning of the XOR gate. The meaning is very simple. It's basically just the OR gate, but then if both are on, it outputs null. That means 0, by the way. For example, it's like an OR gate, nothing is on, so it won't output anything. And again, like an OR gate, if one is on, it outputs 1. But unlike an OR gate, if both are on, it outputs a 0. Cool, right? Well, not really, because this is very, very simple. But now I want to talk cooler. Why did I say it like that? I'm weird. But anyways, these are all the gates. You want to mess around in the circuitforce.org? Then go in the link in the description. But now we need to talk about the Minecraft. We are going in 3, 2, 1. Boom the clut. We are now in Minecraft creative mode. Well, first we want to learn about Minecraft. You can watch the tutorial right here and now. Basic redstone. And if you already know about redstone, skip to what it says on screen. Well, time for the redstone tutorial. Redstone is a type of wire. It can extend like over here-ish, just like we saw in the circuit verse. And the lever is basically an input. It can be no or yes. And the redstone, I cannot type, redstone lamp is basically a output. For example, let's spin on this and the output says yes because it's all glowing. I think you can get that. But you might say, hey, here it's very bright, and if we move this way here, it's very, very dark. Well, if you want to know why that is, listen to me right now. You see, in redstone, there is a limit to how far a wire can go. For example, here it starts at 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It is still a little bit, but it has stopped. It does not have any more electricity to give. But even if it's 1, it gives the same amount of electricity as right over here. Now, let's test it. Let's put it here. You might think, why it's not powering it? Well, that's because we need a target. No, literally, we need a target block. You might think, why, broski, why? But it's a redstone redirector. It redirects redstone into where it is placed, as you can see. Which means that we can do this. And you might think, what? How is that possible? Well, let's quickly talk about that right now. Hard and soft power blocks. You see, when you have a lever, when you have a redstone dust, and it's powering some random block like this oak plank. This oak plank is not something random. It's a soft power block. It can power anything like this redstone lamp, these two redstone lamps, except more redstone dust, as you can see. Well, you might think, how can you hard power it? Well, therefore, we need to look at the thing I'm now about to say. Repeaters and comparators. Comparators are a little bit more complicated, but repeaters are actually quite simple. Let's take a repeater from here example. Let's place it down, and if you can see very closely, it has a small delay. And you don't want to slow it down, do you? So let's quickly type a command named tick rate 2. The repeater gives 2 ticks of delay, or well, 1/10 of a second. Minecraft runs with a tick. 20 ticks is a second. That's called a game tick. But us redstoners, I'm not really a redstoner, I'm actually not that good at it. But for example, me, we call it a tick. But that actually means a redstone tick. You see, a redstone tick is basically the same as 2 ticks. The reason why it's 2 is because 1 tick repeater is 2 game ticks. Anyway, let's see it. Turn it on. Okay, it's so slow. And as you can see, it powered after 1 second. Let's quickly put it back by doing tick rate and 20 because the regular is 20. Anyways, you can put a repeater on more ticks. For example, this is 2 redstone ticks, this is 3 redstone ticks, and this is 4 redstone ticks. Or well, 8 game ticks. And as you can see, here you can actually see a big delay. But repeaters are a little bit more complicated than that because they can repeat the redstone signal. For example, we have a large redstone signal here. We want to transfer the 1-bit or 0-bit data all the way over there. You might think it's impossible. Well, it actually just happened. Let's quickly put it a little further for my cool example. As you can see, it cannot transfer all of the data. Well, let's quickly look at where it's broken. Over here? No problem. Let's quickly put a redstone repeater. Now it's all of a sudden on. Well, let's move it again. We want it much further. It's not working. Bah! Well, just another repeater will do the trick probably. And now it all of a sudden works. But you still have to keep in mind that this causes delay. As you can see, it delays a little bit for the redstone lamp there in the distance. Well, repeaters are just one step more complicated than that. Why is there bedrock over here? Well, that's because it's locked. If it's 0 or a 1-bit, that means that it's just completely locked. And it can't be changed. If it's a 0 or a 1. Now it can be changed. But now it's locked as a 1. So even if this is turned off, it still stays on until we unlock it. You lock it by powering any type of source into it. Just kidding, it has to be a repeater and not a repeater that's powering the source into it. If you want to know more, then you want to watch another basic redstone tutorial. Let's start with the OR gate. Let's quickly have two inputs, one over here, one over here, and a output. Minecraft has basically a built-in OR gate. Let's just combine these two wires like that. You might think, how is this an OR gate? Well, this wire goes there, and also this one. They will go to the same input, which means it's easy to just turn it on. But the AND gate, on the other hand, is quite a bit harder, because we first need to talk about the AND gate. I mean, NOT gate, of course. We can't talk about the AND. Well, we need to talk about the AND gate if we want to talk about the AND gate. But first, the NOT gate. In Minecraft, there's a built-in NOT gate called the redstone torch. The redstone torch is just simple. You power it using a soft or hard power block, and then it outputs the NOT output. For example, here it's on, although if we power it, it's off. Just like what we saw before. Now let's talk about the AND gate. It's a little bit harder than you expect, which is why we have to look again in the circuit. Let's have this and this go into a NOT gate. Both have to go into a NOT gate actually. And then the NOT gate goes into an OR gate. Okay, these need to go away. And as you can see, this is not a NAND gate, but it's a NAND gate. But if you want a NAND gate, you of course just notify it again. As you can see, it's now on, and in every other case it's off. So let's quickly remake this in Minecraft, because we know what we need to do. So here we want a redstone torch on both sides. Boom and boom. Here we have an OR gate and one more redstone torch for our output. Ta-da! But why is it not working? Well, you forgot about the redirection. Well, actually I forgot it, but you might have remembered it. So now it actually works. As you can see in the distance, it's doing nothing unless we do both, where to this turns off, causing this to turn on. But now the XOR gate. It's quite hard to make, but there are much simpler ways to make it. The XOR gate we also need to talk about. You have your two inputs. It's basically just an OR gate. So first, let's add that. Here is our OR gate. But there is one small problem. It's an XOR gate. So we also need a AND gate. Let's quickly take this and put it in an AND gate. Boom and boom. A AND gate. Ta-da! And now what we need to do is we need to turn this into an AND gate, because we need that it's not true. And then that means that I put it wrong. We put an AND gate into a NOT gate, which is a normal AND gate. Bro, these symbols are so complicated. Anyways, well, I did another Oh my godness. Anyways, these we then have to put into another AND gate. A normal one this time. Thank you. Let's put it like that. And then here is our output, the XOR gate. And as you can see, that outputs a 0, because only one of them is true, and we need both, because this checks if both are on, and then it doesn't like it if they are, so it doesn't output the 1 bit. And now this is not true, so it outputs a 0. Let's remake this in Minecraft. Let's take our two levers and first make a simple OR gate. Like this. And now I'll leave the rest to you. Let's see if you know what to do. I'll give you 5 seconds, and if you want more time, pause the screen. I bet you need more time. Anyways, we are back. And the answer is this. We need the OR gate, and we need to put it up high, like this. We also want a AND gate, but how do you get it? Well, first of all, you want to have a repeater over here and over here. Don't question why this works. I know why it works, but let's put it like that for now. And let's have this redstone signal go all the way around. That's it. Right, we need it to go all the way around. Like that. Great. Ooh, that needs to be a bit higher. Like that. Oh, it's not enough. Well, it is barely, but I like to see it more strong. Let's quickly put another repeater, and it is more strong. But we also need the other input, of course. So let's quickly put it this way. Okay, why do I keep breaking it accidentally? Go around. This way. And here we also need a NAND gate. So let's quickly put this into a block, torch, redstone, block, torch, redstone, into this block, double torch, redstone, target block, torch, redstone, and redstone lamp. This might look complicated, but it's actually just an OR gate. Let's turn one of this off and it turns on. Let's turn another one off and it turns back off. You can put only one of them on and it turns actually on this time. Here we are. But there are more and much easier methods to the OR gate / XOR gate. The simple one is the double comparator. I recommend you watch a tutorial, but it's not in this video because it's getting way too long. We need to put the comparator on subtraction mode. Right click it to see this light bulb going. So it's on subtraction mode. And let's put it all the way around. Now we need a lever here and a lever here. We want it inputting in a block into a redstone, and I recommend you give it a repeater because it's a very low signal, because it's subtracting a high number from a slightly less number. So here is our output. As you can see, it's always outputting 1 except if both are on or none are on. The reason is this. When you put this on, it enters a number. This minus this is the exact same, so it enters nothing. But here is off, so this has a higher signal strength because it's always going down. So this has a strength of 2, repeating it has a strength of 15. And if you want the smallest type, I don't have a smallest type. This is the smallest form I have for the XOR gate. Next video, we are not going to talk about the bits because I already have a video on that. The next video, math. We are going to use the bits to make math. But we also need some Boolean algebra. So that's why it's in this playlist. But anyways, for till next time, bye bye!